Good morning. Happy Friday. Continuing on with me at home and you working. Well, some of you actually at home too. So hopefully you've been able to follow along a little bit better with school, with me providing video lessons. Hopefully I can get back to school next week. All right, so we'll continue on with balancing chemical reactions. And we should finish up practice problems 1 through 16 today. Let's see. There's 5 here. I will do 4. You'll do 1 on your own. So let me go ahead and leave. Let's say you do 9 on your own. I'll do the others. All right. Looking at number 6. FeO plus O2 goes to Fe2O3. So again, looking at the arrow here, we just say, make sure everything's on the left and the right are equal. So if I have 1 Fe on the left, but I got 2 on the right, I need to make that 2 on the left also. So now I have 2 Fe's on the left and 2 Fe's on the right. O's are a little different here because I have 2 O's here and 2 O's here and then 3 O's here. Now, some math people you might recognize right away that there's no way I can make these 2 and 2 O's equal to 3, but I can make those 3 equal, well, this being an odd number, I can't make these even numbers odd. So let me go ahead and double this. If I double this, now this 3 becomes a 6. Don't worry about the Fe's, we'll come back to that. That 3 becomes a 6. And now I have 2 here and 2 here. But what if I make this a 2? So now I have 2 O's, 4 O's. So 2, 4 makes 6. I got 6 O's there. Coming back to the Fe's. Now I have 2 Fe's, but I have 4 Fe's. So what do? I make this a 4. I'll cross it out. Let me see if I can white it out. And if I make that a 4 now, that changes the number of O's again. Actually, let's see. Wait a minute. I think I see something. Here, if I have 4 Fe's, 4 Fe's. And what if I get rid of this 2 O's here? Now, that 4 becomes a 2. And 4 becomes a 2. So I have 4 plus 2, 6 O's on the left. Sorry. I guess I just write it out and just make that a 4. I got 4 O's and 2 O's here. And I got 6, 4 plus 2, 6, and I got 6 on the right. And 4 Fe's and 4 Fe's. Not a clean way of doing that. I wish there was a better way to explain that one, but in essence, we end up getting the right answer because as long as I have 4 Fe's on the left, 4 Fe's on the right, 4 plus 2, 6 O's on the left and 6 O's on the right. Because again, ignore that 6, but 2 times 3 makes 6 O's. That's why I got that 6 there. Moving on to number 7. Yeah, number 6 was interesting. Number 7. If I have number 7, hold on. I switch microphones. Actually, no, I think I'm good. Number 7, I have 4 carbons on the left, 1 carbon on the right. So let's make that 4. Got 4 and 4. I've got 10 H's. and 2 H's. Let's make that 10. Actually, I'm going to write those numbers down. So 4 carbons, 4 carbons. I got 10 H's. Now let's make that 10 H's. Still 10. 4 oxygens now. I've got 2. I got 4 times 2. I got 8. And 5 times 1. That's a problem. You'll see in a minute. Because that 4 times 2. Here, let me actually put these down at the bottom, make it a little different. Because now I have 8 O's there and 5 O's there. And then here I have 2 O's. You'll see that 8 plus 5, that's always going to be an odd number. That's going to be an odd number, and that's even number. I can't make that even number an odd, but I can make those odds an even. So in this scenario, you'll see this over and over again. I'll try to point it out over and over again. You want to double everything. If everything works out, except for the fact that you have an odd number, and if the carbons are balanced, as you see, hydrogens are balanced, and the only thing you're left with is one number. And it's easy to do because you have an oxygen all by itself. You have this oxygen here on the right, that's 4 times 2, 8. 5 times 1, 5. Now, no matter what number this would have been, we can easily make this that same number, except for the one problem that it's odd. What if we make it even? By doubling everything. And then, let's see, so let's say double everything. So this was a 1, make this a 2. Ignore the oxygen for now. This 4, make that an 8. This 5, make that a 10. Wrong button. If I make that a 10, so now everything should still be balanced, because if we double everything, then everything should still be balanced. Just like if I have 5 over 5, if I double everything, 10 over 10, it's still the same thing. It's still the same ratio. So if I have now 8 carbons here, now I have, again, 8 carbons over there, still balanced. I have now 20 hydrogens, and over here now I have 20 hydrogens. It was 10, now I have 20. And everything else should work out too, because now these oxygens, I have 8 times 2, so that's now 16 oxygens over there, and 5 times 1, now instead of 5 it was 10. So now 10 oxygen. So 16 plus 10 is 26. Perfect. I need to make this 26 oxygens. How do I make that 26 oxygens? Relatively easily. 13 times 2. Seems a little difficult, but again, with some practice, and we're going to get a lot of practice, you'll start to see when you need to double everything. It happens quite often, and I'll show you the steps to see it. And usually, which we'll later on find out, it's a combustion reaction.